In this lesson, we're going to be looking at working with geometry formulas. Just a reminder, a polygon is regular if all sides are equal and all angles are equal. So for example, here's a triangle. If all three angles are the same, this is an equilateral triangle, and that is a regular triangle. You can also have a regular pentagon or a regular hexagon. All it means is the sides are all the same length and the angles are all the same. So let's talk about exterior angles for a second. Exterior angles add to 360 degrees. So if you want to know what one exterior angle is, you'd have to take the sum of all the exterior angles and divide by the number of angles that you have. So if we write that as a formula for an n-sided polygon, so n is the number of sides that the polygon has, you would take the 360 degrees and divide by the number of sides. So E, our exterior angle, is equal to 360 divided by n. And if we're talking about interior angles, well, they all add to our nice formula, 180 times n minus 2. So if you want to know the measure of one interior angle, you have to take the sum of the angles and divide by the number of angles that you have. So I, our interior angle, is equal to 180 times n minus 2 divided by n. And we're going to use these two formulas for exterior and interior angles in the following examples. Determine the interior and exterior angles for a 20-sided polygon, which is called an icosagon. Well, to find the interior angles, we're going to start with our formula. The sum of the interior angles is 180 times n minus 2. We're going to divide by the number of angles that we have. Well, n is 20 because it's a 20-sided polygon. So now I do the math. 20 minus 2 is 18. 180 times 18 is 3,240. And we divide that by 20. We end up with 162. So each interior angle is 162 degrees. And now to find the exterior angles. Well, an exterior angle is 360 divided by n. So 360 divided by 20 is 18. Each exterior angle is 18 degrees. So in this example, it's just fairly straightforward. You start with your formula, you plug in your value of n, and you solve. In our last example, it's kind of working backwards. An interior angle of a regular polygon is measured at 135 degrees. How many sides does it have? So this time, instead of starting with the number of sides and figuring out what the interior angles are, now we're working backwards. Now we're starting with what an interior angle is, and we're going to figure out how many sides it has. So I'm going to start with my formula to find the interior angle. It's equal to the sum of all the interior angles divided by the number of angles that it has. Well, what do I know? I know the interior angle is 135 degrees. Now I have an equation that I can solve. So I need to use my algebra here to figure out what n is. If you have a fraction, get rid of the fraction by multiplying both sides by the denominator. So multiply both sides by n. Those cancel out. So now I'm left with an equation with no fraction. When you have brackets, you need to get rid of the brackets by expanding. Use your distributive property. So n minus 2 is multiplied by 180. That means n is multiplied by 180, so that's 180n. But minus 2 times 180 is minus 360. So now I don't have any brackets at all. Now I just collect my like terms, and I simplify, and then I solve. So I get n equals 8. The polygon has 8 sides. So these formulas for finding an exterior angle and an interior angle, they're not really new. You haven't had them written down yet, but this is still math that we've done in Spiral 1 and 2.